A very famous type of clustering algorithm is called k-means clustering algorithm. Let's say we have n data. And k clusters. The corresponding prototypes are M1 to Mk. So what does k-means clustering algorithm do? It tries to minimize the objective function, which is defined as this. I will first write it down and explain what it represents. Okay, so we have two sum symbols, which is confusing, but let's first take a look at this part in the red box. What it means is to calculate the distance for all points in cluster J to its prototype and sum the distance up. The distance here is just defined as a Euclidean distance. We could repeat this calculation for each of the cluster, and we sum all the distance up, which gives us h. And k-means clustering algorithm is to try to minimize h. The algorithm is very easy to be implemented because it just includes two steps. But before talking about these two steps, let's now just focus on one cluster. So given a cluster of data, how to calculate the prototype for that cluster? It's actually just the mean of all the data in that cluster. But it's very straightforward and intuitive to understand. Oh, we have all the data set in the cluster. To calculate the prototype of that cluster, we simply just add all the data and then calculate the mean. Okay, anyway, let's move back to the implementation or the description of k-means clustering algorithm. As I said, we need two steps. First, we want to update the cluster assignment, which means for each data, we need to find the right cluster which the data should be assigned to. Update the cluster assignment, okay? The new assignment should be this. For each data, it should be assigned to the cluster. I mean, we need to use the prototype to represent that cluster anyway. So okay, for each data set, I'll calculate the distance between that data set to all possible prototypes. Whichever gives me the shortest distance, I will assign that data to what that prototype represents, that cluster. Second, after the cluster assignment is updated, we update prototype. This is simple. We just need to find the right prototype for each cluster. As I just said, the right prototype will minimize the distance for all data points in that cluster to the prototype. To do that, we simply just need to do this. Where xi is from that cluster. To show that this algorithm can be converged, we simply need to show that both step 1 and step 2 can decrease h, the objective function of this algorithm. If we look into the definition of each step, it's easy to understand. To update the cluster assignment, at that step, a prototype remains the same. But we already use this argmin operator to find the right j, so h should be at least not greater than the previous h after this step. Step 2, updating the prototype. As we shown here, the way to find the prototype of the cluster, we also see this argmin operator. Okay, if we find that operator according to this definition, h will also be decreased. So both steps decrease h. Therefore, k-means clustering can be converged eventually.